Hi, students. We talked about protein synthesis. We talked about transcription, translation, and all of the key components. Let's do a problem. So I talked briefly about a genetic code table. And as you can see on the slide over there, I brought one in so that you can take a look at it. We're going to do an example together just so that you can kind of get used to seeing how it works. So I'm just going to pull up some bases, nitrogenous bases here. Let's say that we have G, T, G, C, A, C, C, T, G. And we're going to say that this one's 5' to 3'. Okay? This is going to be our coding strand. Now, what we need is our template strand in order to get our mRNA. So now we need to match it up. And now we're still working with DNA. So we're going to keep with the thymine. So CAG, nope. CAC, G, T, G, G, A, C. Okay, so this is going to be our template strand. And now we're going to do our mRNA. So that's going to be GUG, CACCUG. And what I do want to point out, here are our codons. So this is going to be mRNA. Now we have tRNA. So that's our next line. CAC, GUG, GAC. Last but not least, so hopefully everybody can see that okay. Last but not least, we have our amino acids. Now our amino acids are actually going to come from our mRNA. So we are looking at GUG. And if I was to take a look at our genetic code table, which is right over there, GUG, oh, sorry guys, let me just move this over. GUG is valine. So this would be VAL. And then we have CAC. So that's going to be CAC, and that's HIS. And then we have CUG, so CUG, and that's LEU. What happens if we have a mutation? So a mutation is a change in genetic material inside of an organism. Sometimes there can be silent mutations where it won't affect any of these amino acids that are being coded for. Sometimes it can be harmful, sometimes it can be helpful, right? So if an organism needs to have a coat color change, right, that genetic mutation can actually be advantageous to that organism. It's really important to remember that the organism itself cannot spur on that mutation. It can't will itself to have a mutation. And we're going to talk a lot about that when we talk about natural selection. Everything with the mutations are completely random. So let's pretend that we have a mutation. So I'm just going to erase this bottom part. Well, let's do this here at the end. So instead of saying CTG, let's do Now I don't know what this is going to do. So let's say instead of saying CTG, we have CTC. So then this would be a G. So then this would be a C and a G. And CUC, does that change it? So CUC, it does not. So that would be something that would not have any effect. What happens if you have something called a frameshift mutation? Now, a frameshift mutation is where 1, 2, 3 different nucleotides can get taken out, and that would completely delete maybe an amino acid or change the shape of an amino acid. So let's say in our genetic code here, we had A, C, and C get taken out. So I'm going to rewrite it over here just so that we can have something to compare to. So now we have G, T, G, C, and then CAC is going to be taken out. So this would be C, T, C. What does that make? So this is going to be our coding strand. We need to make our template strand, which is C, A, C, G, A, G. We need to have our mRNA, so that's going to be GUG, CUC. And then I'm just first saving time. We're just going to go straight to the amino acid. So GUG is still going to be valine. And then CUC is going to be LEU. What's missing? That frameshift mutation completely deleted HIS.